Welcome to this explainer. The explainer, demystifying APIs and the web. Today, we're doing something really fascinating. We're going to peel back those polished, colorful layers of the internet and uncover the hidden, invisible architecture that actually makes everything tick. If you've ever found yourself wondering how your devices seamlessly talk to massive global networks, literally in the blink of an eye, well, you're in the exact right place. We're going to build a mental model of the web using some incredibly intuitive concepts, entirely without any visual distractions, so you can walk away with a crystal clear understanding of what powers our digital lives. Okay, let's dive into this. What actually happens when you enter your email, type in your password, and hit login? I mean, it's a simple everyday action, right? We do this dozens of times a day on our banking apps, social media, streaming services, you name it. Instantly, you're granted access to your private profile. But what is actually going on in those milliseconds? How does your device know it's really you? And where exactly is it checking? To understand this complex tech, we actually need to step away from the computer entirely for just a second. To grasp the true foundation of the internet, we're going to use a brilliant and honestly kind of surprising metaphor from our source material. The digital world works remarkably like a simple everyday tea stall. Now, I know it sounds overly simple, but trust me, this analogy perfectly maps to the exact architecture used by the absolute biggest tech companies in the world. Let's break it down. Let's look at a real-world transaction. On one side, you have you, the customer. You approach the stall because you want something, right? A cup of tea. On the flip side, you have the tea maker. The tea maker has all the ingredients, the equipment, and the actual know-how to make the tea. You verbally ask the tea maker for a drink. They process that order by brewing it, and then they hand the finished cup right back to you. You don't need to know how to brew the tea yourself. You literally just need to know how to ask for it. Now, let's seamlessly swap those physical roles for digital ones. In the computing world, you, the customer, are the client machine. This could be your laptop, your smartphone, maybe your tablet running a web browser. The tea maker, that's the server machine. This is a massively powerful remote computer sitting in a data center somewhere else in the world, just running 24/7. It holds the code, the data, and the processing power to give you exactly what you want. And just like placing that verbal order at the tea stall, these machines have to communicate. When you type a web address like Amazon.com or click a login button, your laptop generates a request. Think of this as your digital tea order. This request is sent out to the server. The server receives it, processes it, and sends back a response. In our analogy, the response is the prepared tea. In the digital world, the response is, well, the actual web page, the HTML, the images, all the data loading onto your screen. And this brilliantly illustrates the sheer scale of this whole process. Imagine a scenario drawn directly from our source. A user is sitting on their laptop in Hyderabad, India, and types in a URL. That request doesn't just happen inside the laptop. It physically travels over the internet, which acts as the transport mechanism, using a set of rules called HTTP or HTTPS protocols. It literally speeds across global fiber optic cables all the way to a server machine physically located in Singapore. The server in Singapore processes it and shoots the digital tea all the way back to the laptop in Hyderabad. And the crazy part? This all happens in less than a second. So now that we know laptops and servers are talking to each other across the globe, we kind of need to look at what exactly they're talking about. A modern application is typically broken down into three main layers. First up is the presentation layer. This is the front-end user interface. It's the buttons, the colors, the text you actually interact with. Second is the business layer. This is the server code, written in languages like Java or Python, which holds all the actual logic of the app. And finally, the database layer, where all your user information and records are securely stored in tables. Together, the business and database layers make up what we call the backend. Now, this brings us to a truly massive technical hurdle. Think about it. The buttons and the pretty colors you interact with in the presentation layer don't actually do the math or check your passwords. All of that heavy lifting is written in the backend business layer, living on a remote server. So how on earth does the front end securely trigger that specific code hidden in the backend? I mean, they speak completely different languages and live on completely different machines.
So the crucial point is the API, or Application Programming Interface. To solve this entire communication problem, backend developers don't just write the core application code, they also write APIs. You can think of an API as the digital waiter at a restaurant. You look at the menu, the presentation layer, and you give your order to the waiter. The waiter takes that order back to the kitchen, the business layer, where the chefs actually do the work. Then the waiter brings your food back. The UI cannot touch the code directly. It absolutely must use the API as a mediator. With this powerful new mental model of front ends, back ends, and APIs acting as those vital mediators, let's go back to our very first question. We're going to put all the pieces of the puzzle together and look right behind that modern login button, tracing exactly what happens the moment you press it. Let's trace the exact step-by-step journey of your data. Step 1, you type your credentials into the presentation layer. Step 2, when you click Login, that button fires off an API request. Specifically, in current web tech, this is called a post request because it's literally posting or carrying your email and password over the internet to the server. Step 3, the API arrives at the business layer in the server and triggers the exact piece of code responsible for logging people in. Step 4, that code now needs to verify you, so it reaches way down into the database layer. Completely invisible in the background, an actual SQL database query starts running. The server code essentially asks the database, hey, look into the users table. Do you have a record where the email matches the one provided and the password exactly matches the one provided? The database searches through its millions of rows. And remember, none of this execution would have been possible without the API delivering the info from the UI to the server in the first place. If the database finds a match, the transaction is almost done. The database tells the server code, yep, this person is exactly who they say they are. The server code then generates something called a session token. Think of this token like a digital ID badge or a VIP pass. The server packages this token into the API response, remember our digital T, and sends it back over the internet to your laptop. Your web browser receives the token, recognizes that you're officially verified, and suddenly the interface transitions straight to your private dashboard. Boom, you are logged in. Understanding this flow unlocks a massive concept in the tech industry, software testing. Because you might be genuinely wondering, if the UI simply triggers the API, why is there an entire multi-billion-dollar industry dedicated specifically to API testing? Why don't software testers just, open the web browser, click the login button themselves, and see if it works? Why bother looking at the invisible API layer at all? The answer lies in the reality of how massive software projects are actually built. The presentation layer, that beautiful, polished UI, it usually comes last. It takes a huge amount of time for designers and front-end devs to figure out the layout, the colors, mobile responsiveness, animations, all of it. If a company waited for the UI to be fully finished before they tested if the app actually functioned, the project would face massive, hugely expensive delays. Let's move to Selenium and see how this builds in a real-world agile development environment. First, the developers write the core backend code. Second, they immediately create the APIs to interact with that code. Third, and this is the absolute key, testers jump in right here to perform API testing. They verify that the code and the database are working perfectly together. It's only much later, in step 4, that the front-end UI is finally finished, painted, and mapped onto those already tested APIs. Our source material provided a phenomenal analogy for this. Testing the API before the UI is ready is exactly like testing a car's engine before the body is built. You really don't need the shiny red paint, the leather seats, or the steering wheel to know if the engine fires up and runs smoothly. By plugging directly into the engine, the API, you ensure the core mechanics of the application are flawless well before you even have to worry about what it looks like on the outside. To actually achieve this, software testers use specialized tools, with one of the absolute most popular being an application called Postman. A tool like Postman allows a tester to bypass the web browser entirely. They don't even need a login page. They can manually craft that post request, type in test emails and passwords, fire it directly at the server over the internet, and analyze the raw response data that comes back. It allows them to verify the engine is perfectly tuned, ensuring that when the UI team finally attaches the buttons, everything just works. As we wrap up this explainer, consider this. Now that you know about the presentation layer, the business layer, the database, and those critical APIs that tie them all together across the globe, look down at your phone or your computer right now. Every single time you refresh a feed, check a weather app, or send a message, countless APIs are silently taking your orders, rushing to servers across the world, and serving you the responses. You're no longer just looking at a piece of glass. You are looking at a massive global network of digital tea stalls serving up data at the speed of light. Keep that in mind the next time you casually click Log In.